Eddy covariance has proven to be a very powerful tool to study carbon cycling. It's a passive way to sample the land surface. The Eddy covariance tower is the physical infrastructure consisting of several instruments intended to quantify the turbulent transport of trace gases between the land surface and the atmosphere. There's three major parts to an Eddy covariance system. One is an infrared gas analyzer that has the capacity to sample concentrations of water vapor and carbon dioxide very rapidly, and a sonic anemometer, which is measuring wind speeds and temperature. And then I would say the third key component is the data logger. Right? This thing is taking in signals from these instruments and logging all that information. I think one of the most amazing things about these instruments sampling at 10 times a second continuously for years on end and just keep going at it 10 times a second and logging all that information. They're pretty impressive pieces of instrumentation. I use Eddy covariance data to understand these ecosystems. The exchange of carbon between the atmosphere and the land surface is kind of an integrative measure of how these ecosystems are working and their function. When we look at these carbon fluxes, it's a net measure of photosynthesis across all of the ecosystem in these plant canopies, and also respiration, both from the plants and from the microbes in the soil. Some of the basic research that we're working on helps us understand plant productivity and production that's related to forage for, say, grazing. There's also an applied aspect in the hydrology. These watersheds, you could think of them as working watersheds, okay? They're providing water that's running off the mountain and used by people. A lot of this work informs the type of water yields that we might get, particularly building on the Reynolds Creek history.